Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre, with me is Z. In this episode, we have some industrial control system fails, some kernel bugs, and a new class of supply chain attacks, or kind of new class. I guess we'll get to that when we get to that topic. I will quickly shout out before we get started that we have a discussion video coming this week where we talk about the future of exploit development and where we think it's going to go. So keep a lookout for that. Also, next week for the podcast, there will be a VOD going out, but it will not be streamed live. That's just going to be that week. It's like a special circumstance. So it's not like we're not going to be doing the podcast live anymore. It's just for next week. But I just wanted to quickly mention that off the top. With that said, though, we can jump into some news topics. So we'll open up with one of the bigger stories, probably the biggest, if you're purely going off of coverage in mainstream media, which was the Florida water treatment facility hack. So this is one of two or maybe three. I can't even remember. We might have three industrial control system based topics that we have today. So yeah, someone managed to breach into an internal ICS panel through TeamViewer, which is just wow, amazing. Um, and they then proceeded to increase the amount of sodium hydroxide, or lye, being distributed in the water supply, which would have effectively poisoned the water supply. It's usually pumped in there to control the acidity of the water, but it's a basic solution, and it's a very strong base. So adding more than is necessary starts to increase the pH of that water. Yeah, this seemed to be a failure on multiple levels. Luckily, it did have a happy ending. The plant employee was vigilant. They sounded the alarm. They were able to get everything reversed pretty quickly. But um,
So I'm not sure if I'd necessarily say it's a failure on multiple levels. It does sound like the plant physically would not have been or would not have been physically possible to do this. The setting was there, would have taken time for it to happen, but even had nobody noticed it. But of course, we already know that one of the people at the plant did notice the change in the chemical level and was warned about that. It sounds like things kind of worked how they should. Obviously, the team viewer aspect is a failure. I'm not going to go against that, but in terms of there having been a breach, they detected it, they responded to it, they did all of that. I don't really think it's as much of an issue on that level. I just think the failure is kind of the team viewer, which I guess can also come down to the fact that a lot of these small water plants, and I don't know how big this one is actually. I should have looked into that. What was what city was this? Nonetheless, I mean, I'm just going to kind of give him the benefit of the doubt.
so
Um,
I
Go ahead.
did see them say, like, they were saying that even if nobody noticed, that there would have been like systems in place to prevent the water from actually being um, poisoned effectively, which I do kind of question, because a lot of other sources that I saw that covered this story did not like mention that. So I didn't know if it was like damage control or something. It's totally possible that they do have those automated systems in place, but it's funny that the only place that said that was I think it was the mayor that said that. But yeah, like, I didn't see that being relayed like anywhere, so I don't know if that was just a fact that got missed, or what. But
Well, I
yeah,
think it's pretty easy for people to look at this one and go for uh, the obvious aspect, which is a water treatment facility was compromised and a very real attempt was made to harm or kill people. I mean,
yeah,
like, that is the noteworthy thing here. The side effect of the fact that the plant may or may not have been able to actually do it, it's not as newsworthy as just talking about the fact that there was that attempt to do it, even if it wasn't possible.
yeah.
Or, I
That's
mean, it
fair.
is possible that that is something that, like, they've just said to kind of downplay the incident. But it does seem fairly reasonable to me that things like this are being monitored for the chemical levels already. You would expect that to be there, so I would more or less expect the water treatment plant to already be watching for dangerous levels of anything to be present.
Yeah, I mean, there's definitely tight regulations when it comes to water plants. There was actually somebody in Discord. This is like kind of a throwaway thing. I'm not like totally sure if this is actually the case, but apparently, like if you work at a water treatment plant and you intentionally do something malicious, it's like 20 years or something in prison minimum or something like that. Which, I mean, it makes sense. You're talking about a water supply that's going to be used by millions of people. Um, but yeah, I mean these treatment facilities are usually taken pretty seriously, which is why it's such a big deal that it's been hit. Um, as far as I'm aware, this is the first publicly known attack on a civilian facility on U.S. soil. And it's one of those things where people have been like worried about this kind of attack for a long time. Um, I mean, Stuxnet was kind of that wake up call that industrial control systems could totally be attacked, even though they're in the real world. They can be attacked from cyberspace, but that was a nuclear plant in Iran. But this is the first attack I can think of on something like a water treatment facility. Maybe it's not the first attack that's ever happened on one or attempted attack, but it's the first that has really seen major coverage and has happened in the U.S. at least. So yeah, I mean this had a lot of the big media machines buzzing and for good reason. So I figured we'd bring it up, even though the story itself isn't too interesting. It was mainly just a team viewer instance that was sitting open for some reason. That seems really strange to me. I don't know why a system that was controlling the chemical levels of water distribution was open apparently to the internet or something through TeamViewer. That's weird. Um,
Oh no, so it does sound like a lot of these treatment facilities gain in these smaller areas, which I'm making an assumption here because I didn't look the size of this area, but it does seem like a lot of them, like it's just kind of a one-man operation in terms of like the IT stuff. So I can understand somebody being, I need, remote access to this, want to see the desktop. Oh, I know about TeamViewer, and just immediately going to use TeamViewer for that.
Even though it's not something you should be doing. Yeah, I
Yeah,
could
like
see that.
it's not ideal, but I could see just like a standalone IT guy being like, that's the tool they know, so that's what they go and use, and not really thinking much of it because, in theory, TeamViewer should be reasonably secure. In practice, that's definitely a questionable assumption. But in theory, you shouldn't have that much of an issue. I mean, I think TeamViewer does have fairly weak passwords by default. I'd hope that was changed, but I have no idea on that front. The fact that it's internet connectable, I'd be more interested in what was on the system, like exactly what happened there. If it was that this system then had access to another, like had access to an app that was then used to do it. Like
Like
I
if
could
it was
understand
lateral
if
movement.
I can understand if it's kind of a step removed, why somebody might not be thinking about that aspect.
Yeah, yeah, and I didn't really see anything in the article that suggested there was like lateral movement there, but you're right. Like it totally could be something like that. There's not a ton of information around how the attack actually happened, or at least not that I could find. So
No, I
uh,
mean, all they really know, well, I don't know what they know at this point, but at least that point it was just viewer was used to open the application and go from there.
yeah, so pretty big story. I think there might be more stuff to come out of it because there is an active investigation around it. So um, possible we see more, possibly we don't, and that's just kept internalized. But yeah, definitely wanted to bring it up. So we can move into a more fun topic, I guess, which would be football. Or actually, we'll save that for the next one. We'll go to beg bounty first. So this one talks about beg bounties, which are described as people who are hoping for a payout for reporting a bug, whether that bug be a real bug or a bogus issue to a company.
Yeah, this is
When that
something we've kind of talked about before. I just haven't heard an actual term being put on it. Actually kind of keying that term big bounty.
I kind of like the term.
Yeah, I think it
It's
hits
good.
the point where people are basically going around with some very easily discovered vulnerabilities. The example here that they give, or at least the first one, um, researcher emails them, hello team, I'm security researcher, and I found this vulnerability in your website. The vulnerability is that there's no DMARC record found, which is not a vulnerability in the website and doesn't really impact the vulnerability in the website or the website
Yeah.
itself. It's, email.
Yeah. So basically, the focus here was on like companies that weren't even running a bug bounty program at all. So like small businesses, kind of thing. And that ranged like these types of samples that were posted on the post were they range from hinting at how a bug bounty would be nice to full out trying to extort a payment out of there. I don't really know if I agree with the extort entirely in some of the context it's used, but being more
It's definitely
pushy, I guess,
happened
for a
though.
payout.
Like the
Oh, for sure.
extortion thing, like I don't know. This is a big pet peeve of mine with security researchers who go and find vulnerabilities in software, go find it in applications that don't have a bug bounty, and then go either demand to get paid or make a big fuss on social media when they realize they're not going to get paid. Now, I'm all for companies having a bug bounty. I think that's part of the maturing in security, maturing the security process, and just kind of stepping up your security in general. A bug bounty is part of that, but it is kind of a later stage. It's once you've already dealt with all of the low hanging fruit and all of that. You've got your regular assessments being done. Then you hand it over to crowdsource some of that extra testing in addition to everything else that you should be doing. So it's just a pet peeve of mine when researchers go and expect to get paid for things because, all these other sites are paying for it. So it's like, let's not even look at what this company cares for or wants you to look at and just do it and demand payment.
Yeah, I mean, the unfortunate reality is a lot of these smaller businesses they do not have the budget to facilitate those types of programs.
They also, yeah, and they
So
just don't have the maturity in their security team to support it either.
exactly, yeah, it's resources. You're basically expecting them to have resources that they don't have in many of these cases. Um, so yeah, this blog post author decided to share some of the things that he's been sent. Um, from smaller businesses trying to reach out, as well as samples they received from Cobalt, which is a cybersecurity firm which markets to some of those smaller businesses. Um, they found each message that was sent to the site owners from the person trying to get a payout was sent to an openly available email address on the site, which is probably a given, and it contained a combination of three things. Low hanging fruit bugs that were found through automated scanning or misconfigurations, or not bugs and just like the issue that you pointed out earlier, Z, with the emails. Copying and pasting of that report into an email template, and then asking where to send the information to receive a reward. So to complement that, he posted three examples in increasing order of potential validity of like the actual issue. The first one was a vague report about an error about login and other negligible issues in your site, and asking if you will pay me as an appreciation reward. Um, this one's kind of funny because there's like it's completely useless as a report. It doesn't tell you anything, and it's very direct about wanting like a payout. So it's like, please pay me out for this very vague information that is useful to nobody. Um, so that was the
Yeah,
first
I mean,
issue.
asking for a payout before you've even given them enough information
Yeah,
is, I mean,
exactly.
some people are kind of stressed for the money. Like, I get the times, eh, but it's just the wrong way to go about it. I mean, security is one of those areas where you need to establish some trust, and it's a lot easier if you're working as part of a bug bounty to do that, to have that trust there. But if you're just approaching as an individual researcher without any bounty being there, you need to give them some reason to actually trust you in the first place. And that's just kind of lacking with a lot of these, in addition to the fact that some of the vulnerabilities being reported are just extremely trivial issues that they are likely already aware of and have made the decision not to deal with, which is kind of another discussion to be had over, what do you report to a bug bounty? A lot of times I've definitely talked on here about some issues I've reported that maybe wouldn't be bug bounty worthy, but when I'm working more when I'm being hired by another company to assess their security, I'm wanting to give them as much information as possible to make sure they're aware, and then they can decide how they go from there. I'm just providing them the information for them to make an informed decision. Whereas with bug bounties, it's a little bit, there isn't as much trust and expectation in it.
Yeah, I mean, there is like if they have an official bounty set up on like HackerOne or whatever, there is the what's in scope page and what they're looking for if they set that up. But that's the problem, right? If you're not running a bug bounty and people are just contacting you through email, it's a lot easier for that spam to come up because there's no official guidelines for what you're supposed to even be looking at. So
Yeah, and I
that's just
guess
another thing that makes running a bug bounty difficult is that triaging part of it.
yeah, and I guess I should maybe clarify that when I'm talking about kind of the reporting of the issues, and asking for money, like if you're doing research on some that doesn't have a bug bounty, I'm not saying you shouldn't report any of the issues. It's just you shouldn't expect payment for it. I think that's kind of a given, but I want to kind of be explicit about that you should still report vulnerabilities. It's just don't expect a payment out of it. We've been getting a lot better. A lot more companies run these bounties, but I still would advise not expecting it if there isn't an actual bounty in place. Like don't invest your time somewhere that isn't going to be paying for it.
Yeah, that's fair. I think where I'd come down on it, I think I'm maybe a little bit less against it than you are. I think it's okay if you hint that you'd like a reward, like asking for it at the end after you've provided information that's actually like useful and not I have an error about your login page.
But that's the other thing. Like providing information that's actually useful also means kind of understanding the actual impact of a vulnerability. Like the DMARC record, I wouldn't really report and expect payment for. Um, in fairness, it doesn't look like they ask for payment on that one. They just say they found this issue. But I mean, when it's somebody who's literally copying and pasting, the vulnerability report out of Nessus or something, or a burp report or whatever. Like at that level, I don't feel like you should be going around with any program that doesn't have a bounty. Because the issues that you're likely reporting are not actually impactful. They could be false positives or things that they're already aware of. I don't know. It just, if you're an actual researcher doing it, it makes a little bit more sense. But when they are just copying and pasting reports from, whatever other software.
Generic Python vulnerability scanner from GitHub.
Oh, that might
but
find
yeah,
something unique.
never know. But yeah, if you want to laugh, you can go ahead and click on the link to go to the post for all the examples. I don't think we're going to go through all of them, but there's some funny ones in there too. But basically, the author ends off the post with some advice for recipients of these messages, saying you just shouldn't engage with them, ignore them. If they cause up a social media stink, like you were saying earlier, some of them might do. I mean, whatever, like
That's not really a whatever, though. That can be a huge damage to a company.
I mean, it if it's a real issue, then I'd agree. If it's one of these bullshit issues, then I don't know if I necessarily agree because if when that information goes out there, the right people will see it. Maybe this is a maybe this is too optimistic of a take, but I think the right people will see it and point out that hey, this is like not actually an issue, and it'll just kind of fizzle out.
I can't
I have
think
seen
of.
that case happen on Twitter before. Um,
Yeah, well, I've seen things that don't gain traction on Twitter, whether or not it's actually because the issue just wasn't legitimate. I do think there's a lot of people who don't know what an issue is, like how to actually judge an issue, who don't know security, but they recognize the application or something. Oh no, I mean, that's a whole nother discussion, though, I suppose.
yeah, I mean, it's when you get to that like extortion type aspect, it gets a lot more muddy. But um, yeah, I think in general, when one of those nonsense issues comes out, I think the community is kind of decent when it comes to responding to those and quashing
People do call them out
drama
for
around
sure.
there. Yeah. So let's move into something that has a little bit more drama then, off the back of that. We have a story about footfall cam, which I'm not going to lie, for a couple days when I was reading notes and looking into this story, I always read it as football cam. I saw it, I was like, oh, that's an F, not a B. So yeah, footfall cam, which is basically it's it's a person counter. It seems like it's a camera that you put up in like a doorway or something, and it counts how many people pass by it. Is how I understood it. And it uses a Raspberry Pi internally, and it has some terrible security, and it had an even more terrible response.
Yeah, and this is
So
part of why bug bounties have become a thing, because this sort of response, the response with legal threats and stuff, was not uncommon. If you go back a decade, so I think it's one of the positive changes in the industry is that it has become a lot more acceptable to do this sort of testing. But yeah, they have several like pretty serious vulnerabilities, mostly just including files, like including secrets, just bad code, lots of issues that aren't entirely relevant here. And I will actually include a secondary link because the same company that makes this product also makes a nursery cam product. And the nursery cam product, as you might guess, also has plenty of vulnerabilities in it.
yeah, so the issues are like not really interesting at all. Like you were said, they were kind of those secrets being exposed. There was a bunch of compiled and uncompiled Python files in the web server directory behind no authentication. It sets up a network with a default password. Admin password can't be changed. Like just really like silly issues.
And setting up the network, it's a broadcasting its own Wi-Fi network with the password that you can change.
Yeah,
So people might run this inside their corporate network and be exposing their entire network to, anybody can just log in on this device.
yeah. So yeah, some pretty like low hanging fruit issues. But where the story gets more interesting is when it comes to that response angle, which was when Oversoft reported these issues. Footfall Cam had reached back out requesting for security consulting, which you'd probably think, well, I thought you said there was a terrible response. Once Oversoft had actually quoted their rate, which was £125 an hour after a deposit of £3,025 with VAT,
Euros.
or yeah, sorry, euros. So yeah, after they'd responded with those rates, they basically like Footfall can basically then use sock puppet accounts to accuse that researcher of extortion because of the rates, saying that €125 an hour is actually like super unreasonable, and that's like however much a year, like 325,000 a year, or whatever,
Two
um,
fifty, a
or
250,000 a year, and yeah, I mean, just to be
250,000 a
clear,
year.
that's pretty fair game, especially when we're talking about a contracting rate. He mentions your annual salary would be, 250,000 euros. But as a contractor, usually you charge about 3x what the salary would be. So that's actually a pretty low rate, at least if you're comparing with rates within the US,
I was
which
gonna
are known to
say
have pretty high rates.
those
No,
are I have
it's
like very reasonable rates for a consultancy like that.
yeah, actually, I'd say it's probably on the lower end.
Yeah.
Nonetheless, they did that. Filed a fraud report with the police in response to it, and obviously all these sock puppet accounts say no to cyber extortion.
Yeah. So this story prompted the other story that you mentioned earlier. Cyber Gibbons had, which was another researcher, noticed they had another product called the Nursery Cam for allowing camera monitoring of children in nurseries. They had some of the same issues, like no encryption, no TLS used.
Well, this
Um,
one, so the nursery cam just seems one of the things that they did is you log into the application and it gives like its JSON response containing all of the IPs and passwords to all of their DVRs for all their nursery cams that they're running. And then your device can then directly log into all of those. So you get access to, well, the UI might hide some things, you get access to like all of the nursery cams, and all the passwords are the same anyhow, so it doesn't matter. But in fact, they publish the passwords over anyhow. It's just like completely the wrong architecture to be doing any of this with.
Yeah, to say that this was designed without security in mind would be an understatement, I think. Um, yeah, basically a lot of meme issues here, and somebody in chat pointed out Bruno Mars MP3 with the. Yeah, I mean the user or the home directory on the Raspberry Pi, um, it contained like things that they assume came from the developer's machine that they just uploaded to it in a production environment, which is really weird. Like it had the Bruno Mars song MP3, it had a bunch of like unused Python scripts, and this there's a lot of like weirdness and like things you
So,
wouldn't expect to see in a production system, hopefully.
in addition to the Bruno Mars thing, they actually, so the Register tried to get in contact with them. And I'll bring that link up also. So the Register tried to get in contact with them, and what ended up happening there is they actually mentioned that they contacted they informed the copyright holder about that Bruno Mars MP3. Are you really telling me that they paid the licensing fees to distribute the Bruno Mars song with their product? Oh, it's just stupid. I mean, this is clearly somebody who's trying to lie to cover themselves. Oh, there's no way that they would have contacted the copyright holder and had a license for it. One, because I'm not even sure you'd get a license to just distribute the MP3. Usually you've got license, like you've got a sync license to, play the song in addition to something else, or like for covers, you've got a ton of different licenses. I don't know what license would really just like you, or what standard license that would be offered by DRM. I forget who has the rights for Bruno Mars, but uh so I was actually trying to look to see what the cost of the license would be. I couldn't find a license that they were offering that would even match just distributing the MP3. So clearly, I don't think that's an accurate statement, but that is what they claimed.
Yeah, but overall, just like awesome security all around and an even more awesome response. Um, this is funny because it's the flip side of the last issue we were talking about, like kind of saying if you find an issue and the company isn't running like a bug bounty program or any vulnerability research program, still submit the issues, just don't expect the payout. And this is kind of looking at the other side of the fence of like this is a model example of how you should not handle reports that are sent to you, um, because these were absolutely like fair issues to point out. And yeah, I mean, you've always said it on the podcast with how you respond is what matters more than anything else, and this is not the way to do that. But yeah, with that said, we'll move into some of our exploits of the day. We have two InfoLeak based issues in Telegram, which lead to a compromise of privacy. In Telegram for macOS, when sending a recorded audio or video message in normal chat, so for anyone who has used Telegram, or for who hasn't used Telegram rather, you can send text messages, but it also does have some rudimentary support for like recording audio messages and video messages and stuff like that. It's not quite as like full featured as something like Discord, for example, but it's there. Um, so when you send those recorded audio or video messages, the sandbox path gets leaked for where that recording is stored. Now that doesn't happen in secret chats, just in normal chats. So that's another thing Telegram supports, and is this concept of secret chats where it's encrypted and you can have like burn messages set up and stuff like that that go through those chats.
So am I
Um,
mistaken? I understood this vulnerability to also be impacting the self-destruction messages. So those messages that after like 15 seconds or whatever after you viewed it should be deleted and they'll be removed from the UI, but the file remains. That was my understanding of this one. That's where I thought it was a more serious issue because it's just leaking the URL, or not the URL, the file path for an MP4 that you've been sent isn't really an issue, in my opinion.
Yeah, so like you said, that is the main issue. I just hadn't gotten that far
Ah,
yet.
sorry.
Yeah, no worries. Basically, um, that sandbox path, it doesn't get leaked in secret chats, but the sandbox path is the same between normal chats and secret chats. So any of the data that gets received in a secret chat is stored there. And like Z said, it's not deleted after that self-destruct fires. And for the yeah, so those self-destruct messages, their intent is pretty obvious. After you've read them or after a certain amount of time, they just delete, but they only delete from the UI side. On top of that, it also stores the local passcode for unlocking Telegram in plain text as well. So those were the two issues: the local passcode being stored in the state as plain text, and any files received in secret chats can be retrieved from the file system even after the message is deleted. Which I'm curious how they handled this issue, because even if now they fixed it with deleting the message from the file system once the message is deleted, what's to stop you from just racing the expire timer to copy the file to a secure location before the burn timer expires?
I'm not sure how much of an issue being able to copy the file would be, as Spectre was just talking about the race. I'm not sure if that's an issue that Telegram's necessarily going to worry about. Because let's say you're able to do that. You're also able to do screen recordings. Like, there's a lot of things that you can do to leak that file. It's not perfect. It's not going to be perfect privacy because somebody has to view it at some point. I feel like at the UI and deleting it would be kind of a sufficient level. Like, anything you can do before they delete it is kind of fair game. Or I'd like it if they took more steps towards making sure people can't like just copy the file out. And I think on mobile applications, this is going to be in that data/data folder. And when it's there, you need root to read that anyhow. So I just get the feeling like if they're deleting it, that feels somewhat sufficient. Maybe some crypto on it, so you need the password, but it's just adding kind of layers of defense on top of it. I guess at that point, it's not really like there's no ultimate protection here. You could always just have a separate camera and take a video of whatever message you get through.
Yeah, so it's kind of interesting because when you get to mobile applications that support similar features like Snapchat, um, they have some mitigations in place for that kind of thing. Like it'll let the other party know if you took a screenshot, for example. And while you can bypass that if you have like a jailbreak or a rooted device or whatever, it also tries to detect and prevent you from using the app when you have a jailbreak. Whereas on desktop, you don't really have that level of like um I guess DRM, for lack of a better word. Like there's not as many protections against people performing those types of self attacks, I guess, where they can run a script that can just pull everything from the secret chats. So you have to have that level of trust that the other party isn't going to do that, or that if they are going to do that, that you don't really care if they do. In which case, you probably wouldn't be using a secret chat anyway. But um,
Yeah, I mean, I kind of feel like the whole secret chat is a bit of a false impression of security
yeah,
because any sort of determined attacker is going to be able to get that information, or going to be able to keep that information. It's just I do believe that deleting the original file is kind of a minimum.
for sure.
Like that is a fail, absolutely. How far you go in terms of defending comes down to really kind of more of a personal opinion on that, because you can always take steps. Like there are always more layers you can add to make it more and more difficult. I wasn't aware of what Snapchat was doing, as you were just mentioning. So I mean that's something I'm not sure if Telegram does that on mobile or not,
I don't believe so.
but I
Um,
mean it just kind of comes down to like there's always more that you can do. Um,
So
but
that
at
is
the same
true. What I will say with Telegram though is it is kind of like the laziest one out there. Um, Telegram is one of those applications where they like to try to pretend they're all about privacy, and that is like basically the entire motivation behind their app, and like security. But they don't take as many of those steps as most other platforms like Signal and whatnot do. which is why I think a lot of people are trying to move people away from using Telegram for privacy. Maybe like it's fine if you use Telegram, but just don't use it expecting like the best privacy, because really like the features are kind of hacked, like hacked in there with Telegram, like half-assed kind of. Secret chats are somewhat secure, but the burn like wasn't implemented properly. Like it wouldn't even burn the files like we're talking about in this issue. Those secret chats aren't even supported on all clients. It's only one-on-one. You can't have like group encrypted communication. Your phone number is easily exposed to contacts. So it's like if you're planning on using like a privacy focused messenger, I would just say like Telegram probably isn't what you should be using, generally speaking. I did kind of cut you off there, Z. Did you have any? Did you have a finishing thought there?
No, no, not really. I guess I will mention out of chat. SCOGs mentioned you can save a file video only in memory. Which I'd kind of argue that well, you can dump the memory and get it, and as they responded in chat, there it is harder to get the file that way. At the same time, that's kind of my point, where you keep adding these layers of defense on something like this. You can keep adding layers. Ultimately, there is a way around. Exactly where you should stop is kind of up to the application. I'm not saying they shouldn't go any further. Like, if they delete it, that's fine. But the fact they weren't even deleting it is like, deleting it is a minimum thing. So this is like a very fundamental failure.
Yeah. So our next post is about supply chain attacks and how someone used confusion with dependency package names to install malicious. I'm using air quotes there because they weren't really malicious. He used it to notify him when code was ran, but they could have been malicious from somebody that was really trying to attack these companies. And they were able to use this type of attack to hit PayPal initially, which prompted them to check other companies when they found it also affected Shopify Cloud, Apple ID, Microsoft, Azure, Netflix, and a bunch of other companies, like probably a bunch of companies that weren't even tested that would be vulnerable to the same type of thing. And it's funny because while this attack is very impactful, obviously, with being able to hit those types of companies, it's also very like trivial in how it works. In essence, it's just about abusing name collisions between private and public packages, like repositories for packages, to get malicious packages uploaded onto public repositories and installed over top of the private ones. And this attack works on NPM, PyPI, Ruby Gems. I'm not entirely sure how it works on NPM, but on Ruby Gems and PyPI at least, if a package of the same name exists on a private and public repository, it'll install whichever one has the higher version number, which really isn't a barrier at all because the attacker can control the version number in their malicious version of the package on the public repository.
Yeah, I guess one key thing to point out, though, is with PyPI, it did require that they were using a specific, that they were using this argument extra index URL to add their, well, extra index to search. If they were using just index URL, it would entirely replace the public half, which would basically prevent the vulnerability by not having the public half of it. It's just because they did basically use extra index URL, that would mean it would search all of the available index URLs.
Yeah, so there were those issues on Ruby Gems and PyPI. On NPM, he didn't really go through how it works, but it seems the public package takes priority over the private ones. I wasn't quite sure on that point. I didn't know if you maybe had better clarification on that, Z.
I don't have better clarification. What I can say, though, is that NPM, I believe, is a bit more difficult to actually run a private repository on. Unless you're using... There are a few, like, software as a service or just software packages that do kind of provide a private NPM, I believe, but I don't believe there's anything as easy as just, like, the extra index URL you have with PyPI.
Okay.
But that I know that doesn't really answer your question. It's just, I think that's part of why we didn't get too much information about it, is because it can be done just kind of in several different ways, basically. And it depends on how somebody decides to implement it. At least that's my understanding. I've not tried to run a private npm.
Fair enough. But in npm's case, it gets a little bit more impactful too, because um, with npm, not only can you get an arbitrary package used if the company has a setup like that, you can also run code just on the install phase of the package with npm through the pre-install scripts, which I'm not sure if Ruby Gems has something like that, but I know npm does because they're used a ton uh, for things like printing out "please send me money," stuff like that. So he used that actually to collect information about the machines that they're installed on. So yeah, using this very trivial attack, he was able to supply chain attack companies like Apple, Microsoft, Tesla, Shopify, Netflix, and others.
Spotify, Apple, PayPal gave a $30,000 bounty, and Azure, with Azure Artifacts, gave a $40,000 bounty. So he made quite a bit from it.
Yeah. Yeah, I mean that's 130K total payout for these issues. So if that doesn't tell you like how impactful this type of attack is, this was just like one of those nasty type of attacks that was lurking beneath the surface, and is one of those things that makes these massive dependency chains so dangerous. I mean, we talked about it fairly recently, I think, in the last episode when we were talking about the post by Google that went into this. But it's not only are you relying on packages that you might not fully trust or even know the existence of due to these chain dependencies, but you also have an issue where if any of those packages are compromised, you're screwed basically. And that's what this attack facilitates. It facilitates attacking those packages by just having that collision on public and private repositories. So yeah, I mean, this is a new attack, but it's also one that's people have thought would be an issue for a while now.
Yeah, it's definitely been something that's kind of been on the back of people's mind. I think part of it, though, is you need to know what the private repository's name is. And that's where, at least with some of the NPM stuff, some of that information gets leaked when you're doing like the application builds. You might be able to see some of the files being included in the JavaScript, that is. So that's where they got some of like the PayPal information from. And they use other open source intelligence to find that information for other systems, but it is some like it has that level of you need that internal knowledge, and they just happen to also find a way of getting that internal knowledge or finding that it was leaked pretty in some pretty obvious areas. Yeah, like I don't think this is the first time it's actually well. See, that's the thing. I'm not sure if this is the first time, or I'm not sure whether this is the first time it's kind of happened from the security research. As Cogs in chat is mentioning, the left pad with npm, and yeah, that's happened where certain dependencies have caused huge problems where they get removed and stuff, but that hasn't been an attacker taking them over exact. There have been malicious, like there have been packages taking over maliciously, but this attack in particular is the name collision, the private versus public name collision, which isn't quite the same as like the left pad or just having the repo taken over, but just when it exists in kind of both that public and private realm, having that collision there resulting in what's expected to be a download of this private repository being a download from the public, which is attacker controlled.
Yeah. So just one of those things where people suspected it would probably happen, or something like this attack was possible, and it's happened. It's hit some of the big companies. So, I mean, what's interesting about this is probably affecting like millions of, or well, I don't know if I'd say millions because I don't know how often private repositories are used, but it could be affecting like a lot of companies. Definitely more than what's mentioned in here, and they just might not know it. So yeah, I mean, this is just something that's lurking beneath the surface that could be taken advantage of. So, um, yeah, just an excellent blog post and one of the most impactful attacks I think that we've seen in a while.
Yeah.
Up next, we have an issue in Libra NMS, which is a Laravel PHP-based solution for network monitoring. According to Shodan search, there's about 3,000 instances of this running publicly. And the issue is a second order SQLI through the passing of raw queries to the Eloquent Object Relationship Manager, or ORM. And that raw keyword there with raw queries is important, because usually ORM will handle sanitization for you. But by constructing raw queries, you're basically saying, let me have the flexibility to specify what I want, since I want to make a complex query. So in their web panel, they have a top devices controller. And this attacker controlled sort parameter ends up getting passed into it through two methods, which is the get traffic data and get processor data methods.
Yeah, I mean, the gist here really just comes down to the fact the application, like every user, is able to add these widgets to their own dashboard. One of these widgets, as Spectre was just mentioning, the top devices. Yeah, that widget, you can add your own set, or you can have your own settings on it. So this isn't like a highly privileged setting area. It's just, you can set like, hey, for my widget on my dashboard, I want it to sort using this field, or this direction actually is what it's expecting you to do. As you can see with the order by raw query, or well, part of the query there, they just inject that sort value, which they get directly from the settings. They just inject that right in there, so you can inject anything you want because it doesn't validate the settings anywhere. You can just enter whatever you want.
Yeah, that settings JSON blob is like the pinnacle of what's going on here. So the attacker, the reason it's a second order attack is an attacker would send one request to cause the injection, being the creation of that widget. And then when the widget gets rendered, it sends a second request, which triggers the injection itself.
Yeah, I mean, so second order in this case, it's kind of like a stored SQL injection in a sense. Where you store the data and then something else is pulling that data out. So you're not directly making the call that's vulnerable. Something else is kind of using it. That's where the second order comes from. A first order would be where you have direct control of the value as it's being injected. This is kind of a step removed from that, which is kind of interesting. I will mention that the sort parameter in general is actually a decent place to look for kind of second order issues like this. Well, not just second order, sorry. It's a good place to look for these sorts of SQL injections, because often if you're just using like the parameterized queries directly, it's a little bit more difficult to bind a variable to the sort order or even to the sort options. Like usually it's possible with whatever you're using for the parameterized queries, but it's usually done in some sort of separate way. Now, this is less of an issue if you're using something like a ORM, as is the case here, or if you're doing like an active record setup. If you're doing that, usually they'll provide a direct way to bind a variable on the sort. Like that'll just be part of kind of the framework or library or whatever. But just because of the fact that it's always kind of a little bit special when it is being done manually, it's a really common place to run into SQL injections, even as parameterized queries are being widely used.
So, yeah, I mean, I was going to say this gets a bit interesting when it gets to taking advantage of the SQLI. Because usually with sort, like you're going to be using like an ascending or descending value. But because the order by query accepts more than one column, you can inject through the extra columns. So to demonstrate that working, they made the payload order by ascending, then added select sleep 10 from dual ascending to the query. Now that payload didn't work if you didn't have permission for any of the devices due to the short circuiting of the query. But they used another known trick to get around that. They used the procedure analyze statements to get that ran, which I didn't know about that trick. I didn't know if you did, Z, from like work you've done in the past, but that one was kind of new to me. But then again, I'm more of a noob when it comes to the web space, so maybe that was just me, and that's used more often than I've seen.
Are you talking about like where they do the benchmark? Okay, I see. Yeah. No, I think that's even on like a number of cheat sheets for SQL injections.
Yeah, fair enough. But I thought it was cool they pointed out that trick. For exploitation, they just use SQL map though, which found the injection points mentioned and exploited them to dump the user table. as a bonus, they point out this could be used as a DOS by running an insane sleep or benchmark query. But as pointed out by somebody from chat, you need authentication to be able to exploit this issue. So despite the Shodan searches showing like 3K results, you need another bug or like some poorly configured instance to be able to exploit the issue.
I want to include this one on the podcast this week just because, I mean, we don't see the second order issues too often.
Yeah, it's been a little while since we've covered one, I think. So, but yeah, this issue was fixed. It was reported on January 6th and fixed on January 6th as well. So, very quick turnaround time there. The fix was shipped on February 2nd. So that's why this was able to be disclosed last week. But yeah, like you were saying, like you don't always get to see some of the second order stuff, so it's nice to cover it when it pops up. Keeping on the topic of hitting web panels, we have another 4 vulnerabilities, this time in Palo Alto Network's next-gen firewall, which is used in the enterprise environment. This is from PT Swarm. So, yeah, like I said, they found 4 issues, starting with the most impactful issue, or most impactful issues, rather. We have a blind OS command injection from authorized user through the external dynamic list functionality for importing objects from an external web server. In the source field, you can pass a result query you can just break out of the command using backticks and get it executed, which will replace the contents from that command in the GET request. So it's blind because you can't see that GET request after it's been interpreted by the server. You'd need to be able to view logs or something to exfiltrate that data, but you can get command injection, and it's pretty straightforward to do. The second issue is another command injection through a different injection point. This was through the REST API. Again, it requires authentication. The issue was in an internal handler for building operation requests. It took a CMD argument and builds it into an XML request to send to the management service. And it then took that data and inserted it into like bin sh-c command for execution, which means this feature was actually intended to run commands, but it was intended to be like a filtered set of commands. There was some checking and filtering done on the service side.
They don't really include what that filtering and checking was, though.
No, they're kind of vague on that point.
So they end up mentioning here that they use CData, just putting the actual command in CData ended up bypassing whatever filters. So I'm not sure if the filtering was actually meant to restrict the types of commands being done.
Yeah, they were a little bit vague. But like you mentioned, they use CData tags to get around that, which we've covered before. Using CData tags for that kind of like evasion. But yeah, so those were the 2 command injections. The third bug was an unauthenticated DOS due to a weird functionality of allowing file uploads. That they allow file uploads on this unauthenticated endpoint, and it'll try to delete them and trigger a cleanup if a 400 error or a 500 error is returned. But when they send a post request to do it, they get a 200, so that file doesn't actually end up getting cleaned up. So if they just spam the server with files to fill up the disk, they can just run it out of disk space, and that'll end up causing issues when you try to log in, because they assume it's because PHP couldn't create a session file on disk. So yeah, it's a DOS, but it's an unauthenticated DOS, so it's definitely noteworthy. The final issue was a reflected XSS in the change password page, which can again be reached without authorization. They inject a PHP self server variable into the page. Now, I was a little bit confused on this because I was thinking, okay, the server variable in PHP, you're not supposed to be able to control as a user. But Z actually pointed out to me that PHP self is kind of special in the way it works because it takes the URL that you pass it. So that's where you can get that injection.
It's not too special, actually. Most of what's in server is just stuff that's from the server's environment. So PHP self is the page being requested, but you've also got like the Query parameters are in there. All of the headers you send are in there. So that's another thing where an attacker would have control. Like a lot inside of the server global variable is attacker controlled, or at least partially attacker controlled. So
Yeah, fair
that's
enough.
not too uncommon. It is generated and it's relevant to like the server's environment. There's also like the get and post and request global variables, or even got a global variable called global, which can be used to access any other variable that's been defined.
Yeah, so I guess the reason you don't see this more often probably is because they're not like most people don't echo out the server variable directly to the page like that. That does seem like so they mentioned the reason they do it, I think, is to make sure that it returns to the same endpoint that it came from by using the server defined path. But yeah, I don't know if I've ever like seen that anywhere before, so that was a little bit strange.
Well,
It struck me as a little bit strange there, but
an easier way to get it to hit, or to get a form to hit the same URL that it's on, is to just not include an action. The default is to hit the same page.
yeah. So it's a bit of strange code that ended up biting them there. But yeah, the reflected XSS is probably the least interesting issue there. The command injections are the big fish. But yeah, I mean, this was a cool set of attacks. Um, Palo Alto, I find it interesting that it hit Palo Alto because I've definitely seen people who have used that software. It's pretty common from what I know. Um, when you get to like enterprise environments for IT and stuff. So yeah, cool to see some issues in that. Um, so getting back to some industrial control systems, we have a Rapid 7 post. This was a critical vulnerability in Advantech iView, which is an SNMP based IoT device management application, which, of course. So, yeah, it's used by industrial control systems. So, it also received an advisory by CISA, that's the Cybersecurity and Infrastructure Security Agency. Um, and this iView application runs as system, and it exposes the capability to modify the configuration file with apparently no authentication, which is really strange.
Yeah, that so this whole report, I feel like they should have, like, with how they did this report, they really should have just released the script that did it, because that's all you really have in this. You don't get any real information about the vulnerability or what happened. I mean, they walk through a little bit, but if you have to kind of look at what all the page actions are in order to get what they're doing. Like, they don't explain a lot. It's just update export path. But yeah, in terms of like the authentication, was it missing? Was there some bypass? Was it just these pages? They don't explain any of that, so we don't know if they just don't have any authentication here, or if it's just these pages that didn't happen, or just happened to be these pages that could be abused. Oh no,
Yeah,
I
there's a
didn't really
lack of
like this write
information
up.
there. Yeah. Um, but one of the things you can change in that configuration, I'm just going to assume that there's no authentication on it. That's just the assumption I'm going off
Well,
of. That
there
might not
definitely is
totally
no
be the
like
case.
the title is missing authentication, so that is clear.
Yeah,
It's
but
more
I mean
why
the
it's missing.
nuances.
Yeah.
Yeah, exactly. Um, so yeah, I'm just going to ignore some of those nuances while covering it. But basically, one of the things you can change in that configuration is the export path for JSP subs. And by changing the export path to the web apps iView directory, you can use the export inventory table functionality to basically write JSP um, in through the column list, which will get written to the file name you specify through the file name parameter on that endpoint, which they don't do any filtering on. You can just include a JSP file extension on that file name. So yeah, they can get a JSP file written to the public directory, which essentially acts like a reverse shell in a way. You visit that page to execute arbitrary commands through the C parameter they set up.
Yeah,
Um,
and I mean you could do whatever you want. This is a pretty classic GSP shell.
yeah. So I interpret this as actually two issues. Um, like they mentioned the missing authentication, but I think they should probably have better validation on the inventory table endpoint as well. Like, is dumping to a JSP file like you shouldn't be able to include the file extension arbitrarily. Um, but I don't know,
Ideally,
maybe
it
there
would
is a
generate
nuance
file
there.
names for you. Like that would be a more
Exactly.
ideal case. Um shouldn't like the column names. Oh no, exporting seems to be a hard problem for a lot of people.
Yeah.
It's definitely a bug farm in a lot of cases. Um, I've done like this sort of attack on like Excel stuff and CSVs a ton. Of it's one of those things though. Like it doesn't seem like it should be that difficult to get it right. Like I said, checking the file names, making sure you're writing to the right place. I'd say, just generate a file name for it, timestamp what it is, whatever the format is. Do that, you're going to be safe. Giving people control over that information just it opens you up to a new level of attack. Validating the columns being used seems like a obvious thing also. Not giving them access to just include whatever information they want, but depending on the level of control they'd have over the data, that may or may not actually matter.
Yeah, I mean, setting aside the security issues, even when it comes to like the dumping and exporting functionality, I feel like just getting a file name generated makes it easier all around. Not only to handle properly and securely, but even if I'm like a user, I'd like the file name to be filled out for me. Honestly, maybe that's just because I'm lazy, but I don't really feel like I should need to control
The
the
UI
name of a
might.
file that gets exported.
The UI
Um,
might be including that. And then
Very well could, yeah.
it's just this endpoint that actually does take a file name, but it's not actually exposed to the user.
Yeah. Um, Now, generally, even though these issues are like pretty serious issues, this interface shouldn't be sitting out on the internet and is usually kept internal. But as we've seen with ICS and just things in general, sometimes things are exposed on the internet for absolutely no valid reason. And if it was, this could lead to an attack on basically any associated SmartWorks enabled network device. So,
Yeah, and there's
yeah, I
also
mean,
the aspect of like a hard outer shell, but like no defenses inside. So get to the perimeter and you kind of have free game on everything.
yeah, you're basically putting all your eggs in one basket at that point of being isolated, which
Yeah,
is
so
never a good idea.
it's not an ideal situation to be in. You usually want to have even your internal devices, even if they're not going to be hit as often or as accessible, it's still ideal to have them locked down as much as you can.
Just another bog standard day in industrial control systems. All right, so we'll move into some of our binary topics. This was a blog post from DBAP Security about a 0-day they found being exploited in the wild from the Bitter APT group. It's a Win32k vulnerability, which it is not really that surprising. Win32k is kind of notorious for being a bug farm, and it was the vulnerability was designed to target Windows 10 1909 operating systems, or rather, the exploit was. But it could also affect 20H2 systems as well, which is like really recent. It was fixed in the February 2021 security update from Microsoft. So this blog post goes into some of the technical details and some of the meta-analysis of the 0-day as well, stating that this was a highly sophisticated exploit. It was almost 100% stable. It tried to do cleanup to prevent crashes. It wouldn't get caught by type-based isolation or the driver verifier. It also does some checks against the target machine, against like the OS build version. It checks for specific antivirus software. Basically, it probes its environment, so it's definitely like a specially targeted attack, which is always interesting. Um, but yeah, getting into the actual issues of the bug, it's a type confusion on the flags field in the WD extra when creating a window, which can lead to an out of bounds read on a free call. So basically, when you create a window on Windows, you can create a window with extra bytes, and it'll call this user mode callback that'll allow you to like do whatever you want to do with that bytes field. And then the return of that callback is stored in the WD extra field on the kernel side as a pointer. Um, Now, if inside of that callback they call the NT user console control function with the handle of the current window, you can basically change that field to an offset, which gets the flag set that makes the field get interpreted as an offset later. Um, you can overwrite that offset's field value with the return of the callback after that flag gets set. So you basically end up with this desynchronization where the flag gets set and then the value gets swapped afterwards, but the flag doesn't get updated. So when the window gets destroyed, it uses that malicious offset when freeing the address, and that leads to an out of bounds data getting passed to the RTL free heap function, which I believe would basically give you like an arbitrary free type primitive. I believe they use that to corrupt another window object that they spray to get more controlled out of bounds right by smashing the window size, which they then use to also replace an SP menu with a fake one to get an arbitrary read primitive, which is kind of interesting because that's a method that wasn't previously known, at least not publicly. So there's some cool takeaways from this blog post that could be used in other exploits as well.
There are. I do like this initial attack.
It's a very
this
fun
initial
issue.
vulnerability. Yeah, it's kind of interesting just because of that callback being there. You're making a further call on the same object, and that's where the desync's coming from. I find that to be an interesting attack surface. It totally makes sense why you're likely to have vulnerabilities in something like that, because it's expecting the userland callback to be kind of performing normally, to not be trying to edit itself yet further and pretending that's a fully allocated object.
Yeah, I mean, like you said, like I think this was a very cool bug. It's unfortunate that it was discovered being used in the wild. Um, but the bug in the exploit itself is really cool because not only is the nature of the bug neat, like the fact that it can offer like almost 100% reliability is also pretty crazy when you're talking about like kernel and modern systems. That's not like a condition that always happens or anything. So this seems like an extenuating like bug and exploit. And that's even leaving aside the fact that it also has that additional like info leak and arbitrary read primitive. Um, so yeah, it's a cool exploit. I will say though, like I said earlier, this bug comes out of Win32k, which is a bit like a free spot of a bingo card, and because of that, it has been cornered off pretty well by Microsoft at this point. Edgium and Chrome do not use Win32k. I don't think Firefox does anymore either, though I might be wrong on that. So it will be interesting. Like it'd be interesting to hear what the userland entry point was for this chain that was found in the wild, because like I said, Microsoft has been trying to isolate things off from being able to even touch Win32k. If they can't remove reliance on it entirely, they try to move things to like IPC or whatever. So yeah, I don't think they mentioned in here what the userland entry was for.
It could be just entirely separate also. Like once they get code execution and the ability to spawn a new userland process. Then they've kind of escaped the sandbox with that, and that's assuming there was a sandbox too. I mean, there are definitely use cases for this that just wouldn't involve being sandboxed.
For sure. And considering this was apparently a targeted attack, it makes a ton of sense. I'm just saying, like, as cool as this exploit is and as cool as the bug is, it's not something you're going to be able to hit from like any context. There are some circumstances around being able to hit this issue. I did struggle a little bit with reading this write up. I had to like go through and reread it, and I had to like reference the diagram and work through it in my head. I think that was just a bit of a language barrier, as you can probably tell if you're seeing the stream. It's not a. It's a. I think it's a Chinese. Is it Chinese? I'm actually.
Yeah,
I can't remember.
.cn, so Chinese.
Yeah. So there might be a bit of a language barrier when reading it, but yeah, this was definitely a very cool bug. And keeping on the topic of kernel and fun issues,
and not enjoyable write-ups.
we have a Synactive post about an iOS kernel vulnerability, which was CVE 2021-1782. So this was a kernel bug in the user data get value function for redeeming Mac vouchers. Mock vouchers, as I understand it, are basically they're immutable resources which are passed through messages and IPC. The entire like mock IPC subsystem for iOS is a beast of its own. It's very like complicated. And the voucher system is also complicated. Um, so yeah, I believe the term voucher comes from the fact that it's a limited resource. It can only be used like however many times it's valid for. But I mean, yeah, Apple just loves inventing like new terms and applying them to their code base. Um, but those vouchers, they can have like attributes such as IPC importance and priority, banks, which I'm not really sure what they mean by like data banks, but they don't they leave that as out of scope for the article, and user data. And that user data is where the issue comes into play. That user data is passed into the user data value element function, which stores some other information such as the hash and checksum and size and reference count. Um, and the reference count is where the issue comes into play with made. It seems the problem comes in when redeeming the voucher. Access to that user data isn't locked, which leads to a race condition on that reference count. And the problem with that is the element's reference count is supposed to stay in lockstep with its parent voucher's reference count. That way, if a race happens somewhere else when releasing the voucher, it will not free the resource from underneath the other caller. So if you can break that synchronization, you can basically get the voucher's reference count higher than the element's reference count. And the way you can break that is by exploiting that race condition. You race two threads that do the exact same thing, which is storing user data and redeeming a voucher. And because the reference count update isn't atomic or locked in any way, shape, or form, it's possible that a reference gets lost essentially by using a stale value in one of the threads. So it goes to increment the reference counter, but what if both threads fetch the same value before incrementing it? Then one of the threads, the reference count doesn't get updated properly. So when the element reference count is less than the voucher count by one, um, that opens up issues in other paths. Because when that same user data store function, when you're replacing the voucher value and that gets called, it fetches the value from the resource manager and it takes a reference on that value. Under normal circumstances, this means that the element reference counter would actually be one higher than the voucher reference count. It wouldn't be in sync, which is totally assumed and expected by the code. Because if another thread goes and tries to release that voucher from underneath the thread replacing the voucher value, it would only free the value with the voucher and the element reference counts match. There's that if statement in the release function. So in this routine, when they're desynchronized, use after free shouldn't be possible. But because of that issue where you could corrupt the reference count with the previous race condition, um, you can basically make it so instead of getting desynced, it actually synchronizes, and that brings that UAF possibility back into the fold. It now means that another thread can destroy the port and get the value freed when it shouldn't be able to, which leads to that use after free. So it's a very complex issue. I might have made a mistake or something. Like I might have butchered something when I was explaining it. When you're talking about iOS and the mock subsystem, it gets crazy when you're talking about um, like background information about that subsystem. If I did make a mistake, feel free to point it out in the comments and call me an idiot or whatever. But as I
Yeah, and
understand
I'll
it,
be honest, like this whole document was really dense to kind of follow what the issue was. I did not
it
have
could have been
fun
written
trying to
better.
reading it or trying to
Yeah,
read it.
for sure. But as I understand it, it's basically desynchronizing the state to cause an unexpected desynchronization to do the opposite of what it's expected to do. It synchronizes the state where it shouldn't, basically. Now, they managed to use this to trigger an info leak on iOS 13 by spraying OS data over the user data element and getting it read out when extracting the recipe from the voucher. It does not. This strategy did not work on iOS 14 because of allocator changes. I'm guessing they have them in like different heap arenas now or something. On iOS 14, they did find a different object they could spray with, being this other type of port. But there's a misalignment with the element size and the port's IPC pointer, which leads to a panic. So it's mainly just a POC that the bug still exists, but it's not nearly as useful of an issue with that strategy.
Yeah, and in
So
fairness, this does still seem like a bug that could be exploitable. You just have to figure out more about what's available for that other use.
You would have to do a lot
Um,
of research. Yeah.
yeah, it'll take some research, but it does feel like something that would be exploitable still. Just gotta figure out how.
Yeah. So I won't lie, I'm a little bit confused on the practical aspect of this, even if you did manage to find another object, though. Um, and it is absolutely practical because this exploit apparently was found in the wild and it was chained with a WebKit bug, which is also worth calling out because it means that this is hittable from inside of the sandbox. But the race for that increment to get skipped seems insanely tight to me because it's one line of code. It's not like the reference count is getting cached on the stack or something like that. It's getting directly operated on in one line of code. My guess is the only reason this is actually hittable in the real world is because it's ARM. So on x86, like if you have an increment, it's I think it's going to be one instruction. On ARM, it will probably be broken down into multiple instructions. Um, and perhaps the other thing that helps here is the iPhone chips are going to be slower than what you'd see on like a desktop PC. Because I've tried to exploit races with Windows this tight on modern x86 chips, and it would not happen. Um, so this is a like insanely tight race, but it does seem from like talking around and looking at stuff that this is actually a very reliable bug to hit. I just don't really fully understand why, in all honesty. It's kind of magical in that regard. But yeah, it's another bug, just like the Windows one, that's very cool and complex in nature. Um, I just wish like you were saying, like I wish the write up was a little bit better. I found myself having to reread certain parts and note things in like a notepad to try to keep track of the state in my head. There was like no, like I feel like a diagram would have done wonders in this write up, just trying to show like the control flow of what's happening. There are no diagrams like that. It's pure text walls and code snippets, and types being used. Like if you're not familiar with Apple terminology and the stuff with their IPC subsystem, you're going to find this very tough to read. Um, which is unfortunate because the issue is extremely cool. So I would say it is worth trying to read through it to look more into the issue because it's a really awesome issue. But yeah, a diagram would have done like so much here, I think.
So out of chat, SCOGs, I think I said that differently from the first time I tried to read it, but they mentioned that the reason it didn't work on iOS 14 was due to an ASLR change. Do you know anything about that? Because I know you already mentioned that you believed it was due to allocator changes.
Yeah, I
Um,
thought they would be allocating it in like a different heap arena or something, so you couldn't get that overlap anymore for the UAF.
yeah, so you'd have
Um,
different objects in there. I didn't look into why it didn't work, so I'm not sure about that, but
Yeah, I hadn't heard of the iOS 14 ASLR stuff. I'm so to clarify for anybody listening, like I'm not an iOS researcher. I have never like exploited the Node A or something on iOS. It's not really my area. I do know a little bit about it through because I find it interesting and I read write ups and stuff, and I talk to people who do iOS research, but it's definitely not my field. Um,
so he does mention chat there. It's a re-randomization of the shared cache region. So that would make sense as to why it's not working on iOS 14 then, and that kinda could fake your allocator understanding. Not exactly, but um,
yeah, I can kind of see how that would loosely fit in. Yeah. All right. Thanks for pointing that out, SCUGs from chat. That's a good point to shout out. But yeah, overall, cool issue. Could have used a better write up though.
yeah, this is like the last one too. I think the core bug is just kind of a fun little bug and interesting thing. So getting that desync and needing to do basically two races to hit the exploit, which kind of makes it a neat exploit too, I guess. But yeah, it's I just had such a hard time trying to read the actual write up.
Yeah, something fun about that bug that I pointed out yesterday because I got into a bit of a discussion about like fuzzing, which we've had that discussion ourselves on like in discussion videos before actually, but um, Like, this is the type of bug, this multi-stage issue, that would like never be discovered by fuzzing. Um, that this like I pretty much guarantee you this was found with manual review. I don't see a way in hell that this could have been discovered by a fuzzer. Maybe very very small chance, like probably higher chance of hitting the lottery, honestly. But yeah, this is just because it's so deeply connected to the state and like order of operations and stuff. That's why I love those types of bugs, is because there's no way fuzzers are catching that. It requires like that manual research and understanding, and yeah, those types of bugs are more fun to me. So we can move into our research segment of the show. Um, First up, we have misusing service workers for privacy leakage. So this one focuses around describing a history sniffing attack, which abuses service workers in popular browsers like Chrome and Firefox. So service workers, for those not familiar with the terminology, they're basically like proxies that run separately from the main browser, and they intercept network requests, um, caching stuff from that request and delivering push messages. I
Yeah,
believe they're
or at
like
least
mainly used
that's
for like those push notifications.
yeah, that's at least one way they can be used. Effect like they can do a lot of things. They can pull down more information. They don't necessarily need to be intercepting requests, but intercepting is kind of one of those key features. But yeah, this is going to be at NDSS, which is next week, I believe. Yeah, I believe that's next or starts on the 21st. So this is still a pre-publication of the paper. Kind of an interesting hack. As I said, it's basically a side channel based on these service workers. We've got the service workers, they may, if they handle a request, then they're going to respond something that is a little bit, or they're going to respond maybe a little bit quicker, because oftentimes these are like pulling from a cache when they actually do intercept and respond to something for you. So what they end up finding was that when being used out of an iframe, or when they would iframe one of these pages, they would be able to detect whether or not a service worker was responding to any of the page requests. And they cover two different ways that they actually determine whether or not the service worker was handling it. One of them being this performance API, and the other one being more of a classic timing based. Now, the performance API just seems like one of the values in there. Um, I believe it was like a work. Do you recall what the value was they were looking for? Sorry, worker star value. That will be non-zero if the worker end up replying. So it basically just leaks directly whether or not the worker replied to the request. And the timing-based one is a little bit more of an obvious timing attack. If a service worker is replying to this and has that page already cached that's replying to, it's going to load a lot faster. So a fairly obvious timing attack there. But that's effectively the gist of the attack. Using that, you're able to determine whether or not a user has already visited a page and thus having it in the cache for it to respond. They go into a little bit more about getting the timing right, so trying to eliminate the startup time for the service worker, some things like that, to basically get more accurate timing information. But the gist of the attack is just leaking that information out of the fact that service workers do respond to pages, and they're able to leak that information somehow, which I thought was definitely an interesting way to get it. I feel like we talked last week about another privacy issue. As out of
Trying to
chat
remember.
also, they're asking, is this break private browser mode? I believe so. I believe this is generally just about how service workers work in general. I don't believe this is even browser specific. I believe this is basically a break in just how service workers are designed to work uh, completely. So this would
Yeah,
break them anywhere they are. Now, service workers, if you're talking by private browser mode like incognito, I don't think the service workers will be installed in your incognito browser unless you've like visited while you were in that incognito session. That might be something to look into, but I don't believe the service worker will kind of break it that way. But like if the service worker was there, it would be able to get this information. And it's just
Yeah,
leaking history. Like you could just know if somebody visited the page as long as that page would have had a service worker response, which is a bit of an ask. Some pages maybe won't have the service worker there, so you're not going to be able to leak whether or not a service worker responds because there is none in the first place. But they did find that a very significant number of major websites will use a service worker, so you are able to use this, but it is worth noting that that is a limitation.
yeah. So it's basically abusing something from the specification. And jumping back to what you were saying with covering kind of a similar vein of an issue recently, I don't think it was last episode, but it was episode 62. I think you're thinking of the excess leaks and redirect flows. Is that what you were thinking of, maybe?
You know,
In terms of
I don't know exactly what I was thinking of. I just have a vague
okay, fair
memory of
enough.
covering something in the covering a history thing. So yeah, now that you mention it, was probably that excess leak one.
Yeah, so that was episode 62. But yeah, like it's a cool paper. It's one of those abusing benign functionalities in an unintended way, or seemingly benign anyway. Um, so yeah, it's not like one of those technical bugs where it's like, oh, there's an integer overflow here or something. It's it's just not considering the way that a functionality can be used. Um, that led to those issues. With that being said, was this mitigated at all? I don't remember if they said that.
I didn't see anything mentioning the mitigation, and um, it it would be hard to mitigate. It's going to require changing the actual spec.
Yeah. So in their conclusion, they do state, in an effort to protect users, we disclosed our findings to the affected vendors. There are remediation efforts currently taking place, including plans for exploring a redesign of Chromium site isolation mechanism. So, like you were saying, it seems like it would be something that would require like a massive overhaul to try to fix. They said they do have a countermeasure, though, an access control based countermeasure to mitigate the impactful attacks while the browser remediation efforts are underway. So yeah, there's like a stopgap put in place, but it seems like something that's going to take some work to fully resolve. But yeah, I mean, cool attack, and it does have some practical implications too. Maybe it's not an easy attack to pull off because of that reliance on requiring the site to use service workers, but yeah, I mean, it's definitely something to consider.
No, and that really just limits the number of websites that are going to be vulnerable to this. But
Yeah,
as long as like that's still a large number of websites. I mean, service workers aren't exactly an obscure feature or any major website, so you can generally expect that to exist.
for sure. With that, we will move into our last topic of the day before shoutouts. That's security things in Linux v5.0, 5.8 from Keys Cooks. So we've covered a few of these in the past. They usually do them with the major, or even I guess the minor, technically Linux releases. Um, Two notable mitigations in this one that were introduced, but there's a slew of new stuff. ARM64 branch target identification support has been added. ARM64 Shadow Call Stack as well. There were also some new capabilities added, like cap BPF to separate from cap sysadmin, some network RNG improvements. But like I said, the big two are the ARM64 mitigations of BTI and Shadow Call Stack. So
And those are
what's
definitely kind of big news here in terms of exploitability.
yeah. So branch target identification is enabled now in both userland and kernel. And what that is it's basically like a low granularity forward edge CFI. Its aim is to kill jump oriented programming or JOP, making it so that you have to use direct function calls. You can't just jump directly to instructions anymore. It checks that they're actually like valid functions. Um, which I will say that will probably be stronger in userland than anything. When you get to kernel, there's so many options that you have where I'm not sure if this really does too much. Not only are there like single functions that you can use as win functions, that you can call that are powerful, but data only attacks are also like a lot more common when you get to kernel land. So BTI I think won't be as much of an issue in kernel.
That's true, but this is a first step towards more fine-grained
Yeah.
CFI. And it is worth mentioning, as this is for CFI, as Spectre kind of mentioned, it's for forward edge. What that means is you have forward edge and you have backward edge CFI, and we actually Shadow Call Stack, that's the other one, that deals with the backward edge. So forward edge, it's literally like your jump, your branch instructions, you're moving forward, and backward is returning. I just wanted to clarify that if you're not familiar with those terms, I figured we should maybe call that out. So what this is attempting to do is make sure any of those indirect jumps that do exist in code, they should only be able to jump to places where they're supposed to jump or known to be allowed to jump to. So obviously when you're doing something like a job chain, you're generally going to be having it jump to just some little tiny gadget that's just going to do like a couple things that it wouldn't normally be jumping to. So by adding this instruction, it's able to take a look at where you're jumping at. Does it have this instruction before it? Yes. Okay, it lets the jump go. If it doesn't, it rejects the jump. And I'm actually not sure exactly what ARM will do, if it'll cause an exception or what, but
it'll probably
fail.
just panic.
Yeah. Well, the kernel might panic in response to that, yeah, but the hardware, exactly how it raised it, I'm not actually sure for ARM. I haven't played around with ARM too much. Either way, like, it'll stop the execution. This is hardware level, or this is a hardware level implementation, so it's going to be fairly strong. However, the weak point is the fact that in this setup, everything is being, like, just any possible target is allowed. It's not doing any sort of fine-grained check to be like, this jump is allowed to jump to these locations. It's some jump is allowed to jump here, therefore all jumps are allowed to go there. And that is generally the weakness with a lot of CFIs. The higher the granularity that you have, usually the more overhead you also have, which is why we don't see it too much.
Yeah, we actually, I wish I remember which episode, but we covered a paper that went into the nuances of how much overhead you start incurring when you add that higher granularity CFI.
Yeah, well, I think we've covered more than one research paper covering CFI.
Yeah, but I mean specifically in kernel, I think there was one that investigated it with like a custom Linux kernel fork or something. Though that might have been a software implementation, so it was probably more severe of an impact. But yeah, it's definitely been a trade-off discussion that's been had before. Yeah.
So, yeah, and then I guess you can go on with Shadow Call Stack, I assume.
Yeah, so Shadow Call Stack is the second one. This aims to protect kernel against ROP through backward edge CFI. So BTI hits JOP, Shadow Call Stack hits ROP. We've talked a little bit about Shadow Call Stacks before. Basically, there's a second stack pointer that gets tracked, which tracks the return values, and that stack is what actually gets used for the return jumps. So even if you corrupt the stack through like a Stack Overflow or something, the return pointer isn't actually going to get used from there. It's going to get used from the protected shadow stack, as it were. What's worth noting here, though, is Shadow Call Stack is a software implementation, not a hardware one, unlike BTI. So if the register value or location of that stack is compromised, this mitigation can be broken because that memory is writable. Whereas if this was enforced by the hardware, they would make it so that that memory couldn't be just written to by anybody. They would make it so it could only be written to by probably the processor itself, actually. So
yeah, my understanding is like CET will implement that on your actual call instructions. It'll do that, so nobody actually needs to be able to write to that. Out of chat, Yashikori asks how much longer till it's done. Assuming you're asking about this is something that is in Linux 5.8. I don't believe 5.8 is getting any sort of long-term support. I think 5.4 is kind of the current long-term support. I want to say 5.10 is the next long-term support one, I believe. At least I know Android, there's an Android 12 branch based on 5.10 now. And they skipped everything between 5.4 and 5.10. So I'm assuming 5.10 is the next one that'll have some long-term support. So you can basically expect to see that in the coming, I don't know, couple years. I guess since we are talking actually about ARM64 specifically, say, do you know when they plan to actually make the shift onto 510? Yeah, they haven't even hit
when Android
5.4
does, you mean?
yet, so we're at least a year out from seeing this on Android.
Yeah, I mean, a lot of Android devices are still running 4.14. So
Yeah, because 5.4 was just more recent. Like, it's just Android 11 and 12, I think, that are hitting 5.4.
and
Like,
even then, I don't think a lot of devices are hitting it until a month or two down the line. I think a lot of devices are still on the earlier kernel version.
yeah, so you've got time before we see this on Android, but I mean, it's coming. I've been surprised by the recent uptake of the Shadow Call stack, just because that has been kind of known about for a very long time. Like, Shadow Stack isn't a new idea. So it's just interesting to see that is being adopted here quite a bit in the last couple years.
Yeah, I don't know. Maybe it's just because hardware, performance has gotten to the point where those sacrifices can be made, or the sacrifice has been minimized to the point where they don't care anymore. That's like my best guess there.
Or
Um,
Clang. 'Cause, I mean, this is the Clang implementation of the Shadow Call stack that they're using. Could be
yeah,
another
that's
thing
worth
as
shouting
Clang
out.
has matured. It's actually become an option to do some of these things.
Yeah, Clang's really been on the uptake for trying to like innovate and add those security features, which is why Android has switched all of their build systems to Clang from GCC. GCC is basically obsolete now in terms of Android, and I think Google's kind of leading that charge. I think there's more projects that are switching over to LLVM as well. Um, but yeah, the shadow call stack stuff is basically intended to be like a stopgap mitigation until pointer authentication support is done, which is kind of interesting too. Pointer authentication isn't really talked about in this post, but Apple has had PAC on iOS for uh, I think like 2 years now. Um, Android, it's still like not really seen yet, and it's both of them are running on the same like instruction set. They're both running on ARX64, and both have hardware support for pointer authentication. But Linux and Android, the way that stuff was built, was really hard to get off the ground running. In fact, when they tried to implement it in userland, I don't know if they've resolved the issue now, but you couldn't even fork to create a new process without panicking, because pack would trigger. So they are trying to work on getting pack into the Android kernel, but it seems like it's something that's taking a lot of effort to do, and it might not be something that we'll see for another year or something yet. So this seems to be like one of those stopgap mitigations. Like here, you can have Shadow Call Stack until we have a more robust system. When pack lands, it's going to be a little bit scary, because the pack's going to kill more than just stack overflows or something like just drop attacks. It's going to kill. It's going to kill a few bug classes, I think, or it's going to make them a lot more difficult to hit.
Yeah,
At
make them
least.
more difficult for sure. I mean, there are ways to deal with pack. They usually come down to having other bugs and other primitives, like getting a signing primitive
You need a
or getting
signing
the leak
oracle.
or something
Yeah.
like that. Yeah, like there are ways around and dealing with pack. So I think more likely what's going to do is it's just going to require, right now you usually might need a bug for ASLR, bug for your actual PC control, and then a bug for your pack. Kind of might be the case.
Yeah.
Which definitely, raises the bar for getting any exploits. Um, yeah, and pack will definitely kill some, but oh no, I'm a bit more optimistic in, what people are able to come up with to deal with these. I mean, there was Dep in ASLR, which was supposed to be a killer too, which obviously hasn't done that job. But we might be kind of entering a bit of a hump.
Yeah, so these are the kinds of things that we will be discussing in the discussion video that I mentioned at the top of the show. Um, is like the future of exploitability due to mitigations like Shadow Call Stack and Pack and BTI and stuff like that. So we'll get into more of a nuanced discussion on that video, but here, I mean, Linux's security has just been taking a massive leap, I think, the last few years. Because before then, I don't really think anybody cared too much, honestly, at Linux when it came to security. But with Google applying the pressure with their Android vested interests and stuff like that, and the fact that ARM has been so good with their hardware mitigation uptake as well. I mean, ARM has been leaps and bounds ahead of x86 the last little while when it comes to trying to fix security issues. Um, x86 is actually going the opposite direction. We're seeing more security issues coming out of it the last couple of years. So
Intel has gotten hit pretty hard with the speculative stuff.
yeah, exactly. But yeah, just keep a lookout on Linux if you're interested in security when it comes to Linux, because those things will be coming, and it will be interesting with the PTI hitting userland, because they said it will hit userland and kernel. That will be relevant for just it's just another thing you'll have to deal with, even if you're not hitting kernel. So yeah, with that said, we'll move into our shoutouts. I don't have any shoutouts, so I'll let you take this one away, Z, and then we'll end off the show.
Yeah, so I just had a quick shout. I don't know or I don't remember if I've talked about this course on podcasts before. So there's a Linux heap exploitation from Max Camper. I'm pretty sure I talked about Max Camper's 44Con presentation. I don't remember if I talked about this course though. So there's a part 1 to this also. I guess I can bring that up. Honestly, he's just a really good instructor. It's about heap allocator exploitation, specifically, PT malloc stuff. So all your house of attacks. So last week, part 2 finally dropped, which includes like House of Spirit. What else they have here? The Poison Nullbite, House of Ehrenhar, Rabbit, House of Lore. Basically some more advanced heap exploitation. Like I said, he's a good instructor. I haven't been through the entire course, especially not this new one yet, but I would be very surprised if it wasn't an awesome course. So I want to kind of shout it out because I believe it was just last week that this came up. So definitely check it out, especially since you are able to get some discounts on them. It's Udemy, so lots of discounts.
The classic Udemy discounts, 71%
yeah,
off.
there's frequent discounts there, so I'd recommend taking a look at it, even if you're not necessarily going to be running into PT malloc all that often. What I like about learning the heap exploitation is it really kind of showcases the creativity that's involved with pretty much any sort of exploit development. In this case, it's, you get these overrides, you get control of something. Now, what can you do with it? And all of these different house of techniques, they take advantage of different aspects. It's not just you overwrite metadata and you get this. You have control over allocation size and this, and what can you do with it? I don't know. It was really reading Malloc Maleficarium years ago that opened my eyes to a lot of this creativity, and just seeing the new attack stuff. It's always been really interesting to me. Even if I don't run into those specific scenarios a lot, I think it's still really beneficial. Yeah, I just want to call out this course and hopefully have some other people check it out.
Cool. So we'll wrap it up there. Thank you to everyone who tuned in. You can catch the VODs on Twitch or on other platforms like YouTube, Spotify, Apple Podcasts, and more 24 hours after the podcast at 6 p.m. Eastern, 3 p.m. Pacific on Tuesdays. Keep a lookout for our discussion video this week, where we do our favorite thing, which is speculating on the future of exploitation. Follow us on Twitter, check out our Discord. We will be doing another stream this week with Teamstar for PS4 kernel exploitation. We don't have an exact date nailed down. Once again, check out the Discord and Twitter for notifications on when that's happening. We're also planning on doing a fun little zombies stream on the weekend. We're going to work out the details of that and let you guys know. But for those who haven't checked out the streams, we somehow on one of the days got onto the topic of Black Ops 1 zombies, and we figured, hey, that'd be a fun stream. So keep a lookout for that. We were kind of tentatively planning on that for this weekend, but like I said, we got to work out the details around that. Other than that, though, we will be back again next week, though not live. We will see you guys either on those streams this week or on the next podcast. But once again, that will be a VOD. We won't be going live, and that's just next week due to some circumstances around that. But yeah, so we will see you guys then. Take care.